that would be SH, functional group, fatty acids, and several divalent and terminate inorganic ions. Itawag siya pod ng argentometric methods ay gagamit ng kaog silver nitrate. Diba ang silver sa periodic table kay AG? Sa AG. Ayan ang pyramid. Argento. Okay? Mas itawag na. Argentometric methods kay gagamit ng kaog nitrate as a silver. Silver yung rin na sa nitrate. So, a titration curve for this method is usually consists of plot of PEG instead of pH and the volume of the silver nitrate acid. Question, Ani? Ano walang signal? So there are three types of endpoints encountered in argentometric titrations. We have chemical, potentiometric, and ampherometric. I will introduce you the definition of potentiometric and ampherometric. This is a lot other topics sa analytical chemistry. We'll focus more on chemical. For potentiometric endpoints, it is obtained by measuring the potential between the silver electrode and the reference electrode whose potential is constant and independent of the added reagent. So, potentiometric and ampherometric, nabilog po siya sa mga klase sa compound called EAM. This is electroanalytical methods. Kung nag-BS-Chem mo, this would be accord sa ANA-Chem 2. This is another set of topic. Pero definition naman siya. Kung sa difference, ani potentiometric and ampherometric. So, sorry sa ampherometric. Ampherometric is by measuring and plotting the current generated between a pair of silver microelectrodes. In solution, they analyze the function of reagent in the volume. So, technically, you are using here cells. These cells sa biology. Anang electrolytic or galvanic cell. Okay, so saan difference between potential and ampero? Potentiometric is, potential is constant. Amperometric, this is current ang constant idea. What current ba? Current. If you can remember, di ba, V is equals to I times R. Okay, hindi siya magamit. This is just base lang po. Kung mag-potentiometric ka na endpoint, you need to have a stable or constant na voltage. If ever mag-amperometric ka na endpoint, current na hindi pa stable. Para mabalo kasamang analyze mo. Wala na submerge mo yung electrode sa silver nitrate. Pero sa ato ang topic na ron, we'll focus on the chemical indicator. Okay? Chemical indicators usually produce a color change or occasionally the appearance or disappearance of turbidity in the solution being titrated. Saan ba sa turbidity? Lubog. Tungkol sa kalubog. Okay? Mauna nung basis karon. Okay. Di ba ito una sa titrations, yung state changes sa color. Karon, combination sa color and turbidity. Kung sa ka-turbid ang ato ang solution. The requirements for an indicator for precipitation titration, muna po siya itawag ang precipitation titration. Di ba mag-form siya o insoluble na compound. So yung kita mo kung insoluble, hindi pa dissolve. O, colloidal ang inyong solution. Bulugda. Okay? So these are the requirements. The color change should occur at over a limited range of P fraction and it should take place in a steep portion of the titration curve. If you can remember sa titration curve na to, usually ang equivalence point is dapit sa ang tunay steep na line. That will be your equivalence point. Question natin. Saan kumana siya, sir? Question. So the requirements, the color change should occur at a limited range or limited range. Pareha po sa indicator, standard indicator. Then, it should take place in a steep portion of the curve. There are three chemical indicators. We have iron-free or Wohlhard method. At sa kasama na siya explain. Chromic ion for adsorption indicators for the Fayon's method. The pronunciation is Fayon's. Fayon's. Hindi na quadrants, okay? It's Fayon's. Fayon's. Okay. So first with the Wohlward method. So Wohlward method is a titration. The titration is performed only into acidic liquid, usually in dilute nitric acid, to prevent precipitation of iron hydroxide. Kaya mula sa pH ang tendency ay formation ani. Kaya ito ang indicator is in the form of iron-free ion. Gikan sa ferric ion. Isa ang chemical formula. From ferric ammonium sulfate. Then, brick red is the color at the endpoints. So, ingana ang results. Okay. At number 1, na pinakauna, the chloride solution, usually ang chloride na produce na liquid solution, color green na siya usually, yellow-green. Okay? So, the Cl solution is treated excess with silver nitrate. So, nagbutan ko ako silver nitrate ani. Butan ko silver nitrate. Ang itsura sa solution is ani. Di ba, turbid kayo siya? Tuhog siya. Okay. Kaya na naman, namin na form na AgCl na solid. Pero, ang imong ibutan would be in the form of excess. Ano, sir? Kung excess, di ba yung ibutan, sir? Di ba mag-back titration? Yes, mag-back titration mo sa Wohlward method. You need to take note that one. Okay? So, kung nag-add ka na rin o excess value of Ag, until such time, pato yung Ag, i-back titrate na mo, this is the KSP value of Ag. Para din yung residual na Ag, kaya siyang sobra din yung Ag, react din na sa imuhang second imuhang, which is CSCN. But before that, napaka-important thing nga buhaton. Okay. The AgCl precipitate must be separated before the next step, back titration with SCN to prevent the reaction. Okay. Kung hindi na mo i-separate galing ang tendency, aning reaction ang itabo. Since AgSCN is less soluble than HCl, equilibrium will shift to the right, causing a negative error for the chloride analysis. To eliminate the error, ang AgCl daw nimo must be filtered and added with the nitrobenzene before titrating with thiocyanate. Ano man, para mag-form siya ang oily layer sa AgCl para dili siya mo-react sa thiocyanate. Remember, wala pa na nagpunta kung thiocyanate. Buhaton dapat natuloy siya para dili mo-react ang AgCl. Okay? So take note of that one sa Wohlward method. Kailangan ka mag-add, i-filter mo yung AgCl or mag-add ng nitrobenzene. Yung feature sa nitrobenzene. You can recall sa organic chemistry, this is nitrobenzene. Okay, kailangan compound. Question, ani? Like question? So, kung bumili nyo, before mo mag-add SCN, kailangan i-treat sa ninyong HCl. Either i-filter ninyo or i-add ninyo ang nitrobenzene sa iyang solution. Dapat sa letter A ha, number 1 pa rin. Dapat sa number 1. So after nyo pagutang HCl, di ba kanina nagutang ng HCl in excess? Na-form na HCl, tapos na-sobra. Okay, ang sobra na yun, pag-titrate na ito siya. Pag pag-titrate mo, mo na rin-issue sa number 2. Okay? Mag-add rin ito ang HCl na i-form na HCl. Manang ASP. The residual silver nitrate is determined by titration with a standard thiocyanate solution. And once na yun, okay na siya ma-react na nan, ato na yung endpoint na yun would be in the form of number 3. Brick red. Precipitate. Okay. Technically, nga rin nakita sa reaction. Na kay Cl. Nag-add ka o sobra-sobra ang AgCl, nakita mo sa imong reaction, ay na-form ng AgCl plus Cl. Diba? O yung solution. This would be number 1. Once mag-add tayo ka o SCN, ang mahitabo, nalagay kayo AgCl plus AgCSCN. Di ba? Ay, sorry. Kailang kabuka. AG din siya. Again, naka-AG, ay naka-CL sa example, mali yung analyte. Nag-add daw sobra-sobra ng AG, naka-AGCL, tapos sobra ng AG plus. O na, number 1. Sa number 2, nag-add tayo ka o SCN, nag-add ka o SCN yung solution, ibali, ang AG din mo nga sobra, mo react sa SCN, forming these two. Okay. Gusto nyo makita ko tayo pag okay ng SCN, wala tayo makita ng AG lagi. Kato na yung FE, na nasa solution na daan, wala siya indicator na mo ba? Katong FE din mo ipunta sa yung indicator, mag-color din na siya kung supra ng imuhang SCN na ba. Okay? At endpoint na din na siya. Okay? Wala na rin siya ang iyang formation. So, ginabak-titrate na nato siya overall. So, nakay CL, nag-add ka o sobrang AG, tapos ma-form yung AGCL o AG. Sobra. Di ba? Once mag-add ka o SCN, so mag-back-titrate mo, AGCL and AGSL siya. This is line number 2 na issue niya. Nag-add ka until na-react na ng AG, masabot na nakay sobrang SCN. Di ba? Ang imong sobrang SCN, gamay lang na siya ang sobrang SCN, magka-red na siya mag-complex tayo. Kaya nagbutang ka o FE sa imuhang plus 1 as indicator. Wala mag-color na siya. Masabot na, mag-stop na tayo na sa imuhang titration. Okay? Question natin sa Wohlward method.
Naki-question?
Tulog ka na method ito i-discuss ha?
Darren, naki-question? Darren.
Okay. Okay? Sige na, mag-isend ng light daw ito. Okay. Okay naman ko na. Okay, let's proceed to sa proper 1. Okay, sir, kung saan mo pagkabalot sir ng Wohlward method, basaha ang question. Was determined by a Wohlward equation. No need to indicate that to 1. Given na siya. Okay, example problem number 1. The percentage weight per weight of iodine is 0.6712 grams sample was determined by Wohlward equation. Oh, kung Wohlward equation yung tuman, nasa yung may dapat. Sir, ang bacterization to kay Wohlward method nun siya. Yes. Bacterization na siya always. After adding the 50 ml of 0.05619 molars of AgNO3 and allowing the precipitate to 4, the remaining silver was backtitrated with 0.05322 molars of ASN requiring 35 or 14 ml to reach the endpoint. Report the percentage weight per weight of iodine in the sample. Start first with even. Are given initially with a 0.6712 grams sample. Then nakay measure of excess. Sa yung measure? 50. Sa ganito, ano 50 man? Okay, usually sa yung bigon, whole number ang volume sa inyong measure. So, isa lang whole volume na rin. 50. This will be your measure. 0.05 liters. Sorry. Even sa taon lang, pwede mo maligo. 50 ml. Then you have 0.05619 molars of AgNO3. Say reaction natin. Okay, ang reaction natin is Ag plus gusto mo yung gila? I. Ano? Nag-add na ako forming AgI. Anong I? Dalawang given. The percentage of weight in I na sample. Ano sa example kaya? Si I. Anong I ang i-react sa excess? Wala ko sa excess. Measure ko na. Ano sa excess? Okay, akin ka ng Ag plus. Ikan sa AgNO3. Ano ba? Kaya mo ka nag-react sa yung I. Pero ito yung sample kaya yung I. Kasi kung react sa yung I, ang precipitate. Dumdumo ninyo, ang AgI is insoluble in water. Diba? Diba? AgI. Halides, except PMS. Lead, mercury, and silver. So, mo, Jude, may precipitation na ni. Okay. Kasi pumunta na. Before na proceed. Even na niya ako, nag-solve. I-even na lang na kung sa reaction para na-amig guide. Yan ako siya pag-solve. AGI, AG plus, and I minus. Okay, sa excess, kung sa itong excess na rin. See? 35.40 ml and 0.05 molars of KSN. Ayan, iputan na rin daw, the remaining silver was back titrated. O, AG na po. AG plus, sino react sa AG? SEN minus. This would be AG SCN. Pili ang K. What are? Cation plus cation. Hindi ba rin Nagets ninyo? Okay. Sir, always na siya yung ana o always na siya yung ana ang ballpark method. Okay, mo man yung gamiton. So, doon na ninyo water dito. Okay. Sunod, let's plan. Kung si buhaton. You start first, since naman siya AG na similar, so, kung ikaw na to ang reacted na AG. So, AG, moles na reacted. Convert na to into moles of I, grams of I, and percentage of I. Follow?
Yes.
Nagikan ang kwan, nagikan ang I. Okay, at given. Diba? Ano na to is, ano ko tatanong? Ano is percentage of I might? Question, ani? Kung saan na magpapalita si grams AG mole na reacted? AG mole na measured minus AG mole na excess. Moles niya. Sige, let's start. Sa measured, we have 0.05 liters times 0.05619 mole over 1 liter. This is 2.8095 times 10 to the power negative 3 moles of AG plus. Diba? Bigat na namin. Ito sa AG plus. Kung kailangan ng UP, pareha naman na. AG plus na ang focus natin. Question, naging ka ng values. I-check sa calculator. Babasin mo rin na calculator. Sakto? Okay. Next, excess. So, bilang excess, 0.03514 liters times 0.05 322 moles per 1 liter. Answer is 1.8731508 times 10 to the power negative 3 moles of moles of SCN9. Okay. Wala pa. Tanawan niyo po, di ba lagi mo siya AG plus ang SCN? Pero, same man ang value ni AGI and AG plus and SCN minus. So, we need na simply assume that this is also 0.1508 times 10 to the power negative 3 moles of AG plus. Pareha na sila. Kasi malito mo nga sir, SCN na lang given, sir. Tanawa ka rin ang balance equation. Pareha na yung value na sila. Kita na nila. Kung balik kili, makita na rin sa sa balance equation. I-times lang na yun. Ratio proportion. Kung duha ka ng AG, saan na rin yun? I-divide ninyo sa AG. Kung duha ka SCN, i-times 2 din yung SCN na value. Pero 1:1 naman na siya. And safe manuana, standard naman na siya nga potassium kayo sa yanik na na siya pa sa ballpark. So, hindi mo mag-ibo kung sa'yo gamit. 1:1 na siya. Okay, next. Ito na to ang moles of plus reactant. I-minus lang. Should be 2.8095 times 10 to the power of 93 minus 1.87.01508 times 10 to the power of 93. This is 9.393492 times 10 to the power of negative 4 moles of Ag plus. So, natatali sa Ag kung mag-react. Question na ni. Sir, yun sa siya, sir, minus ninyo siya ka mag-back titrate man yun.
Tama na eh. 40 degrees Celsius.
Okay na? Ano siya kung ba mag-bread?
Kalapalap siya. Pwede ka ng bahay.
Wala, okay na? Okay. 9.393492 times 10 to the power of negative 4 moles of Ag times, convert na to into moles of I. You have 1 mole, 1 is to 1 na siya, di ba? 1 is to 1. 1 mole of I over 1 mole of Ag times 1 mole of I. This is 126.9. Nagikan? Nagikan? Per unit table. Molar mass sa I. 100 grams of I all over the sample. 0.6712 grams times 100. Your answer should be equal to 17.76%. Example? Oh, ito. Ano siya? Polar reactor siya. Kasi kaya sila. Sample problem is sa titration. Kaya ang polar method is titration ng June. Grabe, ibalik. Kasi di po kabalo, ibalik na. Same process na daw. Polar method. Question, Ani. Dapat question, Ani, atin yung mga numbers. Like na sila, okay? Okay na? Okay na? Okay. Kung na-equal word method, let's proceed to the second method. We have more method. Okay. More method is used to determine fluoride in natural or slightly alkaline solution. Okay, alkaline solution, slightly or not. Neutral dapat. Hindi siya natural. Neutral. Neutral na siya, hindi siya natural. Natural na. Neutral. Ay technically, chloride po usually sa samples ng food at in the natural form. Sa mga samples sa rivers, kana. Gamito ng chloride method. Okay. Use titration with the standard silver nitrate method using potassium chromate as an indicator. O, let's summary ka. Sa Wohlhard method, unsa ang pH sa Wohlhard method? Si pH dapat ni Wohlhard. Kung si Moore kay neutral, unsa man si Wohlhard? Si Wohlhard? Sa iyang pH. Acidic dapat si Wohlhard. Si Moore, neutral. Kung si Wohlhard, ang indicator ni Wohlhard is iron 2, ay iron 3. Kung saan indicator ni Moore? Ha? Sa indicator ni Moore? Potassium chromate, or technically chromate lang na siya. That is CrO4 2-. Take note na ha, ang difference nila. So ganito, acidic dapat si Wohlhard, neutral si Moore. Tapos, ang indicator ni Wohlhard is iron 3. Tapos si Moore is si potassium chromate. Okay. Napay, under question. Unsa ang appearance na endpoint ni Wohlhard? Green red. Honey is sa mali. silver chloride forms. This is initial. Sabutan niyo, wala kayo i-add nga AgNO3. Once ma-add ng AgNO3, ingani ang iyang itsura. White nga precipitate ang mga form niya. Pero tinignan nga reddish. White lang dapat. Mamulong ka mag-add. Once ready to, ano siya, left class before any addition, lemon yellow ang color. Sa example. Okay? Diol, center, monodiol. Naka-slight red-brown coloration, that's your endpoint. Narada yung reaction niya. Diol, sa right hand, strong red-brown color or red precipitate. Mauna ang inyong endpoint. Okay? So this is initial. This is equivalence point. Nara siya fake na pagka-fake. And this is post-equivalence or your endpoint. Question na more. Mga tana ko, sa Wohlhard method, mag-back-titration ka. Sa more, kailangan delay. Delay na. Okay, nakakay-tugtungan lang din sa more method. This method should be carried out under condition 6.5 to 9. Oh, this is neutral. Ano man, kung basic na kayong solution at pH greater than 10, nakakay ma-form or precipitate, which could turn into an error sa inyong experiment. Kung gamay kung tayo yung pH, kung ito less than 6.5 Japon or 7, mag-form ka o mga hydrogen chromic ions or a dichromic ion. So, at this condition, it requires more Ag plus to be added to cause error. So, this is ang result na dapat dito ay basic solution kung anong dito ay acidic yung solution. Neutral lang din siya from 6.5 to 9 pH. Question, ani? So, na yung mga love letter after every experiment ng buhat. Question. Okay. Second question. More method. Titration of, wala naman mo mga more. Pero na nasa problem. Titration of a 0.485 gram sample by more method required 36.80 ml of standard 0.1060 molars of AgNO3 solution. Calculate the percentage by mass of Cl, the sample. Given, you have 0.485 grams. You have 36.80 ml of 0.1060 molars of AgNO3. So, sa kanang reaction, kasi mo reaction ng Ag, ano ang Ag? Pizza. Kasi mo reaction ng Ag, CCl. For me, AgCl. Ano na to? This is percentage of Cl1. Okay. Pata. Plan. Start first with the volume of your Ag+, then ang moles of Ag+, then ang moles of Cl-, grams of Cl-, and percentage density. So, this would be 0.03680 liters times 0.1060 moles of Ag+, 1 liter, times 1:1 ulit, so 1 mole of Cl over 1 mole of Ag+, times 1 mole of Cl, this is 35.45. Nanagitan? Divisible, all or mass. All over the total mass. Pila? 0.485 times 100. This answer should be 28.5%. Sir, ano mo sa lang decimal place, sir? 3 Japon na decimal. Centimeters. So, kasi mas daling more color. Okay, ang Bayes method is different siya kaya naman. Once mo stick ang indicator sa iya ka, mag-change siya ang color. Okay? It is an organic compound that absorbs onto or desorbs from the surface of a solid. This is precipitation. So this is initial, this is equivalence, and this is post. So green usually ang equivalence point. Pero pinaka-distinct na color is pink. Okay, absorption indicators or Bayes method. So it's an organic compound that tends to be absorbed on the surface of the solid in the precipitation titration. Ideally, the absorption or desorption occurs near the equivalence point into that one and results not only in a color change, but also the transfer of color solution to the solid. Example, fluorescent or DCF, this is dichlorofluorescent. In a green solution, ang iyang itsura, kung malimstik sa iya is yellow-green. Pero kung na-EG ka sobra, intensely red. Yan ang term intensely red. Okay? So, ang indicator niya is DCF or fluorescent. Okay, Rita, Bonhart method. Unsa ang indicator ni Bonhart? Iron? Green. How much more?
Potassium
Bromate. How about si Mayans? Fluorescent or DCF? Okay? Fluorescent. Next. Absorption indicators are organic compounds that are meant to be absorbed onto the surface or the solid precipitate. Okay? So during titration, naka-AgCl colloids mga form, which is sa imuhang structure. Ang imuhang indicator is mustik siya sa iyang adsorb. Okay? So, at initial point, the surface of the precipitant particles will be negatively charged due to the absorption of excess Cl in the surface particles. Okay, muna siya itawag ng fluorescinate, kaya naman, glow in the dark pa siya ay indicator. Muna yung ang itsura. Fluorescent galing, glow in the dark. Okay? A diffuse positive counter-ion layer with surrounding particles. Muna yung itsura sa yung Cl plus with indicator. Come on. Yes! Kanang sulod sa glow stick, fluorescent na siya. Kanang sulod sa glow stick. Okay? Nabuto. Okay? Okay? A diffuse counter-ion layer with surrounding particles. That is the first one. Dayon, at early stages, is once before yung HCl, di ba, orbit na siya. Orbit.
Glow din.
Diba?
Sir, ang pagsabot yan, sa glow stick ay stick.
Stick.
Wala siya. Wala na sila.
Wala sa mga na wala na. Glow stick ba? Ano? I-green dito.
Ano si glow in the dark ka nga?
Okay? Anong HCl? One of the increase na yung HCl na yung solution, perfect na yung solution. Tapos, kung give off na siya, ang inyong indicator, pingit na sa iya kamitin. So, yellow-green ang color niya, ang walang ang nitrate. Kung stop ang nitrate kung, okay, wala siya equivalence point at the center, wala na excess Cl, neutral na po siya, take note, neutral. Rika, Bonhart, acidic, more neutral, Bayes neutral. Kaya, gawin ang ninyo. Large neutral siya. Ngayon, at equivalence point, the right-hand beaker, ang excess na Ag, ma-absorb siya sa AgCl, causing it to have a red na reaction. So, ayan ka mag-stop sa imuha. Ibalik, kung sobra na yung AgCl, ang imong Ag plus mag-stick na po dayon. Kung wala na ibatuan yung Ag plus. Dayon, kung mag-stick yung Ag plus, kanin mong mag-green, mag-turn na siya ito red. Once mag-stick siya sa, kung nakita niyo na yung plus na rin, may mga plus sign. Okay? So that would be the Bayes method. Okay, here are some important reminders when doing the Bayes method. Absorption indicators works best when they do not precipitate out silver ion and they bind the precipitate only. present to produce color. So dapat, exclusive lang yun siya na AgNO3 binutan to Cl na siya. Conditions that favor the formation of colloids. You need to have a fast addition of reagents, add dextrine to record coagulation to dextrine. Kanang dextrine is a chemical para dili mo clump ng inyong indicator with the sample. Okay? pH control, important. So the pH must be in neutral and avoid light. Sir, saan na siya, sir? Musiga man yung fluorescent dye, hindi na ka mag-titrate anang ang init. Musiga na siya, yes. Muna ang tendency karon na, tendency ko na last sem. Ano yung kamo sa iya, tingala rin, magsalud mo sa 204, nag-waving, tingala rin, pantanan, palong tanan. Kaya chemical is sensitive sa light, o degrade man ang kasamit sa light. So if ever, kung mag-transmit ang tumuhol, kung dahil sa fifth floor, i-cover na rin yung itong foil or palungan yung suga kung nakakita sa 204. Okay? Eh dapat, sensitive na siya sa light, kaya mag-decompose na siya. No problem, for Bayes method. Bayes method, laborious di siya kadagan kay given, kung gamay na kayong kailangan. Okay? A sample of a dicing salt was to be analyzed for chloride content using Bayes method. A 1.10 per gram sample of the dicing salt was weighed in an earthen pH glass and 50 ml of water, 0.1 grams of dextrine, and 5 grams of BCF indicator was added to the glass. It took 39.41 ml of 0.542 molar of silver nitrate to reach the endpoint of the titration. What is the percent chloride in the sample? Okay, percent chloride daw. Even. You have 1.10 grams of sample. Dayon, 39.44 ml of 0.542 molars of AgNO3. Sir, kailangan ipunta ang dextrine o BCF o 50 ml? No. Ay, hindi man na kailangan. So, wala na yung given. Anon? Sino naman anon? Percentage of Cl9. So, reaction, Ag plus Cl, this is AgCl. So, you have 0.039.45. 44 ml liters times 0.542 moles per 1 liter of Ag plus. So, pili na ko ang volume of Ag plus, 2 moles of Ag plus, 2 moles of Cl9, grams of Cl9, and percentage of Cl times 1 mole of Ag, what is 1 gram? Times 1 mole of Cl, 35.45 grams. So, ang nagiging 35.45 molar mass per the table. 1.134 grams. Times 100, you have 63.89. 4 significant figures.
Gara kayo.
No, yun na. And then, ang nakakalitin niya, iwan, ulit na siya. Kina? Okay, isa reaction. Then, memorize. Kina? Memorize. Memorize. Kasi masabot sa residual direct. Residual back titration. Direct, no need. Direct, no need. pH, acidic, neutral, neutral. Titrant, AgNO3. Then this is back titration. AgNO3 and AgNO3. Indicator. Ano yung DCF? DCF. Then endpoint value. Take note. Memorize. Memorize. Tulo na ako sa time.
Asa
Okay, let's proceed to the titration curve or precipitation titration. Okay, titration curves for precipitation reactions are calculated in a completely analogous way for methods of titration involving strong acid and strong base. Base gathering kinsa si excess of sealing, biting. Biting sealing. Okay, pareha siya sa pag-calculate ninyo sa strong acid and strong base titration curve. Minsan excess, siya ang base nito. Instead na pH, PAG yung pagtawag. Okay? Most indicators for argentinite integrations respond to the changes in the concentration of silver ions. Because of this response, titration curves for the precipitation reactions usually consist of a plot of PAG versus the volume of silver reagent. Another example. Ikot ko di ay, sa strong acid at strong base, atong ginagamit is KW. Diba? KW. Strong acid, strong base. Pero dahil, atong gamiton dahil is KSP. Mabali. Okay? So, same yung siya ng process sa strong acid at strong base na calculation. Sige, sa example. Okay, calculate the silver ion concentration in terms of PAG during the depletion of MnL of 0.05 NaCl with 0.1 HNO3 after the addition of the following volumes of agent in equivalence point at ml, at equivalence point 25, and after equivalence point. Given AgCl ASP is 1.8 82 times 10 to the negative 10. Question, sino na ang buhaton? Ano pa? Sino na? Even ka o 50 ml 0.0500 molars of NaCl and 0.1000 molars of AgNO3. Unknown PAG of A to C. Follow? Okay. Sa itong first step, galing ba sa ingani? Malinaw na? Ha? First step. Wala ba? Ano yung first step? Ha? Analyze and titrant. So you need to identify first your analyze and titrant. That's your first step. Uy, nalimpa na. Naging mo pinakauna. Sa token ko, hindi ba ito pinakauna? Kasi pinakauna. Eh, kasi ba yung tayo ito analyze? Dua, balance chemical equation. Katulong, equivalence noise. Number one, titrant. Kung sa man yung clue nga titrant, analyze mo siya na. Isa itong analyze. Fix ang volume o ang concentration. So therefore, dito itong analyze. NaCl. Isa itong titrant. AgNO3. So tutuko na ninyo, ang imuha coordinator na NaCl, imong titrant AgNO3. Pero sir, always pa ng AgNO3 na sa titrant? Yes. Ay ano man, tanawa balik. Saka. Tanawa. Wala din siya ginawa ka argentinite titration. Kasi ginagamit na titrant. AgNO3. Okay? Sige, next. Number 2. Ito number 2? Balance. So, balance. AgNO3 plus NaCl. Kasi mo 4. AgCl and NaNO3. Sunod. Number 3, equivalence point. Is a given na 25 na pamutang. So, ano yung pagkita sa equivalence point? Masugod ka sa 0.050 times 0.05 molars of NaCl per 1 liter times 1:1 1 mole of AgNO3 times 1 liter na yun, malinis na confusion. 0.1 moles of Ag. Answer ninyo is 0.025 liters or 25. So therefore, given ito na sa letter B, 25 ml. Ha? Oh, ibutang mo siya. Pwede naman ako ihanap yung equivalence point. Kung ingon ako at equivalence point, you need to find the volume of the equivalence point. Okay, let's start with letter A. 3 equivalence point region at 10 ml. So, yung ginabuhat galing sa strong acid, strong base. Ano siya notes?
Initial point.
Initial? Hindi siya initial. Hindi initial lang yun. Initial. PEG, malupit na lang eh. 3 equivalence. Nag-add na lang ako 10 ml. Sa itong same process, itong strong acid, strong base. Ito nag-add ka ako before equivalence. Find the, sige, find the niya. pH. pH yung pinapita. Mole of each reagent. Okay. Mole of NaCl and then kay mole of Eg and O3. Pag itaon yung si excess limiting. Kasi ito pag itaon, excess limiting. Ha? Excess. Kaya naman, sobra man siya sa solution mo. Okay? O, bilang moles ng NaCl. You have 0.05 times 0.05 moles per 1 liter. Ilang moles in NaCl? You have 2.5 times 10 to the negative 3 moles of Cl. Follow? Okay, next. AgNO3. Bilang volume AgNO3. 0.010. Ano gikan? Even. Times 1,000 1 liter. This is 1 times 10 to the negative 3 moles of Ag plus. It's just excess. C 2.5 Cl. So therefore, this is concentration of your Cl. Ito naman ang excess. Diba? If ever makatungtong mga itong parinit ang strong acid, strong base, kung minsan sa excess, makapagin lang ang concentration. Okay. So this would be 2.5 times 10 to the negative 3 moles minus 1 times 10 to the negative 3 moles over total volume. Hindi naman. 0.010 plus pila? Pila man? 0.050. Ano yung sir? Even. 50 ml single layer. Nag-add ito 10 ml. Answer natin pila? Pila? Okay. Wait, kasi pangutana. Kasi may pangutana. Hindi ka mga values na. Ano ba yung CCN? Ito yung panitaan na? Excess man siya. This would be the excess. Pila answer? 0.025 molars. Okay. Kung saan ito pinapalitan na rin? Sa ito ano? PEG. Malagi ka ng PEG. Kung i-negative log mo ang Ag plus. Cl pa rin. Saan ka na siya, sir? Saan ka na? Cl pa rin. Pag nakita. Nanawa na kayo sa kagiven. Equal. Ano kayo sa kagiven? Ay importante. Kung sa'yo KSP expression na ni, you have Ag plus times Cl. Nakay KSP? Na, sir. Nakay Cl? Na. Kasi mong kita? Ag plus. So, para makita niyo mo yung Ag plus, this will be equal to KSP over Cl minus. This is, bilang KSP? 1.82 times 10 to the negative 10 over 0.025 molars. Ilan, sir, ani? You have 7.28 times 10 to the power of negative 9. Oh, may tao ng PHG. Saan na ninyo? In negative log. O, negative log is 8.40. So that would be the PHG of your letter A. Nakapalo? Pareha na ba siya sa process? Strong acid, strong base. Pareha siya. Ang nakailahi lang ay KSP. KSP award. Question natin. Sir, pareha ba niya mula sa strong acid, strong base, sir, nga at equivalence point is 7. Kung sa itsura at equivalence point, very sir. Okay. Naraman ko i-assume na po din siya rin. Para pareha na siya. Question natin. Ulit question natin ng mga values. Kaya i-erase na lang letter A. Letter A lang sa ating i-erase. Hinapin ang 1, 2, 3. Dapat makabalo na dapat mana. Uy, dapat kabalo mo sa expression sa KSP ha. Tuluan pa yung na. KSP is equals to AG plus CN. What if sir, natunay mga squared sir? I-apin po. Sure. Question natin. Kina? Dito na ako? Okay. Kinaw? Okay. Okay. At equivalence point, we need to assume an equivalence point. Tingnan na tayo ng ginamang reaction in full equilibrium. So therefore, KSP is equals to Ag plus and Cl minus. Dahil, since, remember, at equilibrium, at equivalence point guys, at equivalence point, you need to take note na the concentration of Ag plus is equals to the concentration of Cl. So therefore, this will be equal to KSP to concentration of Ag plus squared. So, ano yung pagkita sa PAG? Ag plus is equals to square root of KSP. Square root of KSP would be equal to 1.82 times 10 to the power of negative 10. This is 1.3491 times 10 to the power of negative 5 molars. That is Ag, di ba? Pagkatapos yung mga PAG negative log, this is 4.87. Sir, always ba na at equivalence point? Yes, always. Just the square root of KSP and negative log din ninyo dahil nakakuha ang PAG. Question natin. Nalilay ka letter B. Pareha na siya sa 7 ninyo. From what? 7 ninyo sa equivalence point is strong as strong base. Ani, yung negative square root of yung base. Yan ang parang. Question nani? One, at equivalence point man, equal naman ang HUCL. Kung equal na siya, di ba ma-times 2 na lang siya? Square area po na siya mawala. Pareha sa concentration, di ba? Okay na? Question lang. Sa mga question. Sir, ang magiging 1.82, walang given na na ay. Ang magiging ng PAG, sir. Negative log na ng AG. PAG. Para sa PH. P-value na siya, P-value. Question, hani? Hala? Okay na? Okay, let's proceed sa letter C. For letter C, pareha siya sa letter A nga mag-solve. Sa letter first galit, hapon, magtawa ng mole molecular na value para makabalo kung isa ang excess. Pila? Pila? 0.1. Alin? Over 1 meter. This is 2.6 times 10 to the power negative 3 moles of Ag and O3. It's an excess. Ag and O3. So this is based on concentration of Ag plus. Minus na yun. 2.6 times 10 to the power negative 3 minus 2.5 times 10 to the power negative 3 all over. Pinatutan mo yun. Then we add 0.026 plus 0.0 pila? 50 liters. Answer, Annie? Hindi naman. 1 point. Tatlo. 1 point. 3.158 times 10 to the power negative 3 molars. Bilang PEG. Bilang PEG niya. 2.88. Hindi na kailangan KSP. Gamitan ng KSP sa equivalence. What election excess? Question. Question? Okay, let's proceed to the effect of concentration on the inflation curve. Let's analyze the following people. With the volume of Ag and O3, maraming ang PEG values. Ang iyong gamiton is 50 ml, a 0.05 and 0.1 versus 50 ml, a 0.005 o 0.001. Kung sa'yo mo ma-compare ano silang kuha, ano siya mas concentrated? This is diluted. Okay? Take note. Tanawan na yun ang mga values na yun. You have 8, 7, 6, 4, 2, 2, 1, 7, 6, 5, 4, 3, 2, 3, 1. 32. O sa'yo na-observe? Sa'yo na-observe in intervals niya. Ano yung first one? Sa'yo na-observe? Tatlo ang interval. Diba? 8 to 7, 7 to 6, 6 to 4, 4 to 2. Tatlo. Diba? How about this one? Gagmay. Okay. Ano ang effect sa concentration? Ingani. Kung magpunta ng titration curve sa kani, this will be letter A. And this is letter B. Take note, naradali niya ang resulting na titration curve. Ang letter A kanang black, ang letter B kanang blue. Let's compare. With 0.1 molars of HNO3 curve A, the change in pH equivalence point is large, about 2 pH units. With the 0.01 reagent, the change is about pH units. So, lang po ang units sa concentrated is sa diluted. Okay. Pero, pronounced gapon ang iyang equivalence point. An indicator that produces a signal in a 4 to 6 pH region should give a minimal error for the stronger solution, for the concentrated solution. For the more dilute chloride, the change in pH in the equivalence point region would be drawn out over a very large amount of volume so that to determine the endpoint accurately would be possible. So in other words, tanawan ko, compare na to sa iyang figure ha. Letter A, for this one is the concentrated nga solutions. Letter B is diluted. Kung saan mo ma-observe sa concentrated versus diluted? Si concentrated, medyo taas-taas ang iyang stiffness or sharpness. In compare sa katong letter B. Letter B. This is letter A, this is letter B. Okay. Take note, the more mas dako imong concentration, the more mas steep ang imuhang or mas short ang imuhang titration curve. Okay? So, sa ani, kung mas steep yung or short yung titration curve, mas pronounced ang imuhang equivalence point. Dali din mo siya makita. Okay? So, dapat, kung sa'yo gamitin dapat sa concentration, concentrated or diluted? Concentrated dapat siya. Para mas dako ang steep or sharp sa iyong equivalence point, tapos mas pronounced ang iyang equivalence point. Okay? Tanawa ka yung difference sa ilang duwa. O? Letter A, taas tayo ang steepness. Mas pronounced. Unlike ang letter B. Okay? So, walang effect sa concentration. The more dako yung concentration, the more mas steep or sharp yung equivalence point, mas pronounced ang imuhang equivalence point. Dahil hindi mo makita. Question nani? Wala yung question? Again ha, kung dako yung concentration, mas pronounced or mas steep, ay mas sharp yung titration curve, mas pronounced yung equivalence point. So, mas dali mo makita yung equivalence point sa imuhang titration. Okay, how about, okay, this is the titration curve. Increase sharpness of the break of the endpoint in the more concentrated solution. Okay, let's proceed to the last part. Effects of reaction completeness and titration curve. Kung saan ganitong concentration gali, the more na ang concentration, the more mas steep, mas sharp ang curve. So, mas pronounced ang equivalence point. Dahil sa reaction completeness, mag-base na sa ASP na value. The more mas gamay yung ASP, the more mas steep or short ang imuhang equivalence point or yung curve. Mas mas pronounced yung equivalence point. Hindi siya daw. Pronounced dapat. Okay, note that the change of pH and equivalence point becomes greater as the solubility products become smaller. That is, as the reaction between the analyte and silver nitrate becomes more complete. So, as you can see here, para na may imuhang titration error, dapat ang imuhang ions forming should not be much larger than 10 to the power of negative 10. So, compare sa graph. Isang mas na-pronounce na, isang na mas pronounced na short na P. C, I. Dalawa ang PKSP ni I. Gamay na ko. Gamay. Okay? Ayan, importante rin mas pronounced daw ang less than times 10 or 10. Okay? So therefore, hindi ko makagamit ang I, BR, or CL, pero hindi ko gamitin ang IO3 o PR3. Ngayon naman, dalawa bali ang hirahang, wala sila na-fall sa range, at the same time, hindi pronounce ang hirahang pag-steep. So, nakabutan na sila daw, much larger than 10 to the power of negative 10, do not. Mas tapo pa daw sa 10 to the power of negative 10. So, ang negative 8 o negative 5, mas tapo pa na sila. Okay? So again, nasa ma-review, ang concentration, the more na ko ang concentration, mas steep or sharp ang imuhang titration curve. Therefore, mas pronounced ang imuhang equivalence point. Bali dayon siya sa reaction completeness based sa ASP. The more mas gamay yung ASP, the more mas steep or sharp yung equivalent ang imuhang curve. At the same time, mas pronounced yung equivalence. And that will be all sa atuang discussion. Question. Before we proceed na sa complexitation titration. 1 hour lang. Hindi na iba. Ha? Hindi naman na. Okay. Question. Bilang siya sa slide 39 out of 68 na siya. So, mga 168, no? Please na ba tayo? Complexitation titration. Okay, nalalay ako sa complexitation, no? Nalalay siya sa complexitation.
Wow.
Nalalay mga formula na, nalalay ang formula 2, 4, 5. Pero hindi na mag-baby. Titration, kaya mo siya. Okay, wala siya coordination ng verse. So, yan na siya. Then, with color, kasi class A. Then, trigonometry reduction. And, ano siya, in terms of pH, calculations. Then, water hardness study. Question, Ani, ano na siya? Module 6. So, makuha na siya in next meeting sa Thursday next week. Yes. Thursday next week. Ano sa Thursday next week? Ano sa Thursday next week? Sa? You have 16. Ano ito ang long? Hindi mo yung 17 ka masunod lang yung sleeping games. Ano ka? 17 to 18. Hindi mo yung pasok. 19. Monday na lang quiz sa Monday. Ngayon, 16 din ang next ka lang quiz. Friday na masunod ka. Okay, ang finals, kay 15, June 15. Yes. Okay, naman po, naman yung completion na sa'yo na diba sa summer? Diba na yung completion? No, ako galing ang PA, yung reporting sila yung discuss. Kaya producing those in surgery. So, don't go and siya, reporting ko siya. Okay mo, kamara lang report eh. Kaya po, ang long quiz din na tumalas will be on June 7 or June 4. Ako ba na kayo ito kaya sa natin? Okay, again ha, schedule na lang ha. May 7 ang atuwang, May 7. May 6 ang atuwang for long quiz. 16 tayo ang atuwang 5 long quiz. O, one na discussion na lang sa 10 sa 40. Ang compensation, one na. Ha? Assignment? Monday. Monday. Monday na, 2 weeks na po ay. Marami na mag-lunch yun. 2 weeks na po. Oh, 3 weeks na po. Long quiz ha, okay, coverage. Module 5. 10 items, multiple choice. 5 items, problem solving. Okay, pagkatagalan ko o coverage. Number 11. Number 11 is calculation sa neutralization. Number 12, titration of acid base strong to strong. Magkatagalan ko kung ang mga point. Kung pre, equivalence, or post. You take note that one. 13. Tama. 13, back titration. 14, weak acid, weak base. Magpili lang ako sa kalitsun. 15.
Bonus.
Diba? Alimot ko.
alignment. Sir, balik daw, sir. 11.
Sir, ay classification.
Sino pa?
Sila, kasi this,
Sir, 15, sir.
hindi ako masyado.
Okay, number 11, precipitation titrations. Number 12, calculation of strong acid, strong base in titration curve. Pagpili ko sa region. Number 13, back titration number 13.